Howe was 85 years old. He could not walk. He could not speak. And in the spring of 1980, the United States Air Force wheeled him into a blacked-out hangar to show him a secret that would not become public for another 6 years. The lights came up on a machine with no tail, no fuselage, just a wing, vast, black, alone in the dark. He had designed that exact shape 50 years earlier, and the government had spent 3 decades trying to make sure the world forgot it. They handed him a model. His hands were shaking too badly to hold it steady. He picked up a pen instead, and on a scrap of paper, he wrote a single sentence that stunned the engineers standing around him. He would be dead within the year. He would never see this aircraft fly. So why show a dying man a bomber he'd never lived to see take off? What debt were they finally trying to repay? His name was Jack Northrop, and the government that buried his life's work was the same one that came back, decades later, to steal it. John Knudsen Northrop never earned an engineering degree, not one day of formal training. In 1916, at 20 years old, he walked into a small aircraft shop in Santa Barbara run by 2 brothers named Lughead, men who would later change the spelling of their name to something easier to pronounce, Lockheed. He was hired as a draftsman, nothing more. He was there to draw lines other men had already imagined. But something happened in that workshop that no diploma could have taught him. Lockheed in those years was not a company. It was a garage with ambition. Northrop worked shoulder to shoulder with the men building the aircraft, watching every panel, every rivet, every pound of unnecessary weight get bolted onto a machine that had to somehow leave the ground. He began to see what nobody else in that shop seemed to see, that every part of an airplane that wasn't the wing was, in some sense, a compromise. A tail kept it stable. A fuselage held the crew and the cargo, but neither one produced a single ounce of lift. They were dead weight the wing was forced to drag through the sky. By 1929, that idea had hardened into an obsession. Northrop left the security of Lockheed and founded his own company, Aviation Corporation, for one purpose: to build an airplane that was nothing but wing. No tail, no fuselage, just a single flying surface swept and shaped so that the whole aircraft became one continuous lifting body. Other engineers of the era treated the tail and fuselage as necessary organs. Northrop treated them as tumors, structure that existed only to fight the drag it was creating. It was a radical, almost heretical idea in an industry still built around the biplane. And the man pushing it had no letters after his name to make anyone take it seriously. What he had instead was a decade of hands-on proof. Every ounce of structure that wasn't producing lift was an ounce working against the airplane. Cut everything down to the wing, and the wing alone, and you would build something faster, more efficient, and further reaching than anything flying with a tail behind it. He sold Aviation within a year. He would found and lose control of company after company chasing this single idea for the rest of his career. But by 1939, he had built something that would carry his name into the history books, the Northrop Corporation. And the mission he wrote into it from day one was the same one he'd carried out of that Santa Barbara workshop 2 decades earlier. Strip the airplane down to nothing but lift, and let physics do the rest. It was a philosophy that would make him one of the most visionary aircraft designers of the 20th century. It was also the exact same philosophy that would get 5 men killed, destroy his life's work with a blowtorch, and leave him waiting until the final year of his life to be proven right. In April of 1941, the United States Army Air Corps issued a request that few engineers on Earth thought was possible to fulfill. Not a fighter, not a medium bomber, a machine that could take off from an airfield in Kansas, cross an ocean, strike a target in the heart of Europe, and return home without landing once. The requirement was staggering on paper: a cruising speed of 275 miles per hour, a service ceiling of 45,000 feet, and a range of 12,000 miles while carrying 10,000 pounds of bombs to a target 5,000 miles away. Nothing built by human hands had ever come close. The reason for the demand was simple and terrifying. Britain might fall. If the Nazis took the island, the United States would lose every forward air base it had in Europe, and any hope of striking back at Germany would have to originate from runways on American soil. Washington needed an intercontinental bomber, and it needed one that could exist in a world where America stood entirely alone. Two companies answered the call, and only one of them built the aircraft the way anybody expected. Consolidated Aircraft, soon to become Convair, proposed a machine of pure brute force conventional engineering. 6 enormous piston engines, a cigar-shaped fuselage nearly as long as a football field, twin tail fins, multiple gun turrets bristling from every angle. It would become the B-36, and it would eventually hold the record as the largest piston engine aircraft ever built, with a wingspan longer than a modern airliner's runway approach. It was everything the requirement asked for, built the way every bomber before it had been built. Add mass, add power, add structure, until the numbers on the specification sheet were satisfied. Northrop looked at the same requirement and saw something else. He did not believe the answer was to build a bigger, heavier version of what already existed. I believe the fuselage itself was the problem. A 50,000-pound tube of dead weight the engines had to drag across an ocean for no reason except to hold the tail on. Strip all of that away, he argued, and the aircraft would go farther on the same fuel, using less structure at less cost. It was not an incremental improvement. It was a direct challenge to the idea that a bomber needed a body at all. In August of 1941, General Henry H. Arnold, the man who would go on to lead the entire Army Air Forces through the war, personally visited Northrop's plant to see the idea for himself. He brought with him the Assistant Secretary of War. What they found was not a finished airplane. It was barely more than a wind tunnel model and a stack of engineering drawings, but Northrop had something the paper alone could not convey: total conviction that the shape was correct and the willingness to bet his company on it. It worked. On October 30th, 1941, the Army Air Corps confirmed its approval, and on November 22, a formal contract was signed for a prototype designated the XB-35. Northrop would not be asked to prove the concept on a full-size bomber first. Instead, the Army authorized something almost unheard of for the time, a 1/3 scale flying demonstrator, the N9M, built purely to answer one question: could a tailless flying wing actually be controlled in the air by a human pilot, or was Northrop chasing a beautiful idea that physics would never allow to fly straight? It was a staggering risk for the Army to take on an unproven configuration, and an even bigger one for Northrop, a company with no completed bomber program to its name, going up against an aviation giant building what would become the largest bomber in history. But Northrop had done what only a handful of engineers in that era ever managed. He had convinced the most powerful air commander in the country that his outsider's idea deserved to be built at full scale, on the same footing as Convair's conventional giant. The Army was no longer choosing between one bomber and another. It was funding two entirely different visions of what an airplane could be and letting them race toward the same impossible mission. One of them was built by adding everything the requirement seemed to demand. The other was built by removing everything that wasn't the wing itself. Northrop had won his seat at the table. What came next would decide whether his philosophy could survive contact with the real world, and whether the same principle that got him there would be the one that eventually tore his life's work apart. The first time the world saw Jack Northrop's idea actually leave the ground, it happened on June 25, 1946, at the company's own airfield in Hawthorne, California. There was no fanfare, no press conference, just a strange tailless shape rolling down the runway on 4 engines, 172 feet of wing from tip to tip, carrying nothing behind it and nothing in front of it except itself. Onlookers who had spent their whole lives watching airplanes take off said the same thing afterward. It didn't look like it should fly. It looked like a piece of the sky that had simply detached and started moving. And then it did fly. Smoothly, calmly, exactly as Northrop had promised it would for 15 years. That first flight, the XB-35, was only the beginning. The propeller-driven version had proven the shape could work. What came next would prove it could compete with anything else in the sky. In 1947, the Air Force ordered 2 of the airframes converted from piston engines to jet power, replacing the 4 massive radial engines with 8 Allison turbojets buried inside the wing itself, their intakes flush with the leading edge, their exhausts hidden in the trailing edge. The new designation was YB-49, and on October 21, 1947, Northrop's chief test pilot, Max Stanley, took it into the air for the first time. Barely a week earlier, at that same stretch of California desert, Chuck Yeager had broken the sound barrier. Now the Mojave was witnessing a second kind of history, a bomber that looked like nothing that had ever carried a bomb before. The numbers that came back from testing silenced almost every doubter who had called the flying wing a dead end. The YB-49 reached a top speed of 493 miles per hour, faster than most fighters flying at the time, let alone a bomber. It climbed to service ceilings above 45,000 feet, well past where enemy anti-aircraft fire could reach. In April of 1948, Stanley took the aircraft up for a single continuous flight of more than 9 hours, holding altitudes above 40,000 feet for 6.5 hours straight, an unofficial endurance record that no other bomber of its size and weight could match. Northrop's obsession with removing every ounce of unnecessary structure had produced exactly what he'd promised back in that Santa Barbara workshop, an airplane that could go farther, faster, and higher than anything built the conventional way, because it wasn't dragging a fuselage and a tail through the air to do it. Then, in February of 1949, the flying wing got the moment that seemed to confirm everything. A YB-49 took off from Muroc and flew nonstop across the entire country to Andrews Air Force Base outside Washington, D.C., covering the distance in just over 4 hours, an unofficial transcontinental speed record. President Harry Truman, reviewing the state of American air power, ordered the crew to fly it back over the Capitol at rooftop level, right down Pennsylvania Avenue. For a few minutes, the strangest bomber ever built passed low over the government that had funded it, in full view of the men who would decide its fate. It was by every visible measure a triumph. The outsider's airplane, the one with no fuselage, no tail, and no precedent, had outclimbed, outrun, and outendured the very institution that had once doubted it could fly straight. But triumphs like that one rarely arrive clean. On the return leg from Washington, ground crews discovered that oil had never been replenished in the engines during the stopover, a lapse serious enough that some on the program quietly wondered whether it had been an accident at all. Nobody could prove otherwise. It was a strange, unsettling footnote to an otherwise perfect flight, and at the time, almost nobody thought to connect it to anything larger. They had no reason to. As far as the public could see, Jack Northrop's radical idea had just flown over the White House and lived up to every promise he had made about it. The wing that removed everything unnecessary had become the fastest, highest-flying, longest-enduring bomber in the American arsenal. What nobody watching that flyover could have guessed was that the very same design principle responsible for those records, the absence of a tail, the absence of the stability that came with one, was already, quietly, becoming something else entirely, a flaw that had already killed men and would soon kill the program itself. By the summer of 1948, Jack Northrop appeared to have won every argument he had ever made. His flying wing had shattered performance expectations, flown over the White House, and set an unofficial endurance record no other American bomber could touch. Now the Air Force wanted more of them, not as an experiment, but as an operational weapon. In March 1948, Northrop proposed a new mission for the design: strategic photographic reconnaissance. Strip the aircraft of everything needed only for carrying bombs, add cameras and radar equipment in their place, and the same long-legged, high-flying wing that had impressed Truman could become America's eyes over enemy territory in the opening hours of a future war. The air staff studied the proposal and liked what they saw. The flying wing's range, altitude, and growth potential made it, in their own words, a realistic candidate for a mission no other American aircraft could yet perform as well. On June 12th, the Air Force issued Northrop a letter contract to begin engineering work. 2 months later, on August 12, 1948, that letter became something far larger: a production contract for 30 RB-49A reconnaissance aircraft. For a company that had spent 7 years building prototypes, one at a time, by hand, this was the moment everything had been leading toward. Full-rate production, a real fleet, a permanent place in America's strategic arsenal. But buried inside that same contract was a detail that should have worried Northrop far more than it did at the time. Of the 30 aircraft ordered, only one would be built at Northrop's own plant in Hawthorne. The remaining 29 were to be built by Convair, the same company whose conventional B-36 the flying wing had been racing against since 1941 at Convair's government-leased factory in Fort Worth, Texas. The Air Force framed the arrangement as simple efficiency, pooling Northrop's engineering with Convair's experience in building aircraft at scale. On paper, it was a routine industrial decision. In practice, it meant that even at the height of its triumph, Jack Northrop's own invention was already being handed, piece by piece, into the hands of his rival to build. At the time, almost nobody inside Northrop treated it as a warning sign. The company was riding higher than it ever had. Production lines were expanding. Engineers who had spent years defending the flying wing against skeptics now found themselves fielding calls from the Pentagon instead of arguments. Jack Northrop, the draftsman with no engineering degree who had once had to beg the Army Air Corps to take his idea seriously, was now being treated as one of the most important aircraft designers in the country. His philosophy, strip away everything that isn't the wing, had been vindicated by a stopwatch, an altimeter, and a presidential flyover down Pennsylvania Avenue. The 30-aircraft contract should have been the beginning of the flying wing's real career. A fleet of Northrop's radical design, quietly watching over the opening days of the next war before any enemy radar could catch a warning. Engineers at Hawthorne began planning for a production run that would, for the first time, put the flying wing into the hands of operational squadrons rather than test pilots. None of them yet knew that the very same month their production contract was signed, the aircraft's performance was already starting to unravel under closer scrutiny, and that the man who controlled its fate in Washington had reasons of his own, reasons that had nothing to do with airspeed or altitude, for wanting Jack Northrop's company to disappear into somebody else's factory altogether. The same design principle that had just carried a bomber across the country in 4 hours was, at almost the exact same moment, quietly turning against it. A tailless aircraft has no vertical stabilizer holding its nose in line with the direction of flight, and no horizontal stabilizer damping its tendency to pitch. Northrop had engineered around this problem as best the era's technology allowed. Small fins at the trailing edge, careful aerodynamic tuning, an autopilot system meant to smooth out the wing's natural instability faster than a human pilot's hands ever could. For most of the flight envelope, it worked. But push the aircraft into the wrong conditions, and the flying wing revealed exactly what it had given up by removing its tail. Without that long lever arm at the back of a conventional fuselage, the airplane had almost nothing to resist a sudden yaw or a snap into a spin. Test pilot Robert Cardenas, who flew the aircraft extensively, later said he had personally warned fellow pilot Glenn Edwards that the YB-49 could rotate backward in a stall, a violent, disorienting maneuver that gave a crew almost no time to recover. Jack Northrop, when he heard the claim years afterward, insisted it was aerodynamically impossible for his design. The men who were flying it were not so sure. The airframe itself began showing its age under the strain of constant testing. On April 26, 1949, fire broke out in one of the engine bays during a test flight, an incident serious enough to require $19,000 in repairs, a significant sum for a single mishap on an aircraft the Air Force was supposed to be moving toward mass production. It was not a catastrophic failure, but it was one more data point in a growing pattern, one more reason for skeptics inside the Pentagon to start asking whether the flying wing's radical shape came with radical, unsolvable costs attached. And the rival that had once seemed beaten was no longer standing still. While Northrop had spent the second half of the 1940s refining a shape built around a 1941 requirement, an entirely new kind of aircraft had appeared in American service, the Boeing B-47 Stratojet, a fast, swept-wing jet bomber that owed nothing to the wartime thinking behind either the flying wing or the B-36. When Air Force planners compared the proposed RB-49A reconnaissance variant against the B-47, the verdict was blunt. Northrop's reconnaissance wing, weighed down by the extra fuel and equipment its mission required, would be slower than the newer jet it was meant to complement. In December 1948, just 4 months after the 30-aircraft production contract had been signed, an Air Force Review Board recommended the RB-49A program be terminated outright. The recommendation became official cancellation the following January. By April 1949, the production contract for 30 reconnaissance aircraft, the one that had felt like vindication only 8 months earlier, was dead. That November, a parallel program to convert existing airframes into a strategic reconnaissance configuration was canceled as well. Piece by piece, without a single dramatic announcement, the flying wing's future was being disassembled from the inside. Northrop told himself and told his engineers that this was simply how procurement worked. Programs rose and fell with shifting requirements, and a company that had already delivered aircraft faster and higher than anyone expected still had a case to make. What he did not yet fully grasp was that the ground underneath the entire program had already shifted in a direction no amount of flight test data could fix. The man who controlled that ground was Stuart Symington, Secretary of the Air Force, and by 1948, he had grown convinced that the American aircraft industry could not afford to keep supporting every company that had scraped by during the war. Symington believed in consolidation, fewer, stronger firms building aircraft at the scale a modern Air Force required. And he had a specific consolidation in mind. He wanted Northrop Corporation folded into Convair, the very company building the rival B-36. The pressure did not arrive as an order. It arrived as a suggestion, then a series of meetings. Northrop was introduced to Floyd Odlum, head of the Atlas Corporation, the Wall Street holding company that controlled Convair. The two men discussed what a merger might look like. According to Northrop's own account, given publicly only decades later, the terms Convair proposed were not a partnership between equals. They were closer to an absorption, one that would have stripped Northrop of control over the company that bore his name and the flying wing program he had spent nearly 2 decades building. He refused. He had built his workforce at Hawthorne over years of struggle, he later said, and he was not willing to hand his people, or his life's work, over to be run by somebody else's factory in Texas. Symington did not take the refusal well. Shortly after Northrop declined the merger, the order came down that would end the argument for good, not through a memo explaining the decision, but through a silence that made the decision unmistakable. The contracts, one after another, simply stopped. And the same government that had ordered a presidential flyover of its newest bomber less than a year earlier was now, just as quietly, preparing to erase it. Northrop would spend the rest of his life insisting the technical problems were solvable and that the real cause of what happened next had nothing to do with engineering at all. The Air Force's official position was that the flying wing had simply failed to keep pace with a rapidly advancing jet age. Both things, in the strange and uncomfortable way that history sometimes allows, may have been true at once. What is certain is that by the end of 1949, the aircraft that had flown over the White House 18 months earlier no longer had a production contract, no longer had a reconnaissance mission, and no longer had the political protection it needed to survive what was coming. Glenn Edwards was 32 years old, a decorated combat pilot who had flown more than 50 missions over North Africa in a war that had already tried to kill him once. By the spring of 1948, he had moved on to a different kind of danger, the kind that came from strapping himself into aircraft nobody had ever flown before. He kept a diary, a habit from his combat days, and in May of 1948, not long after he joined the team at Muroc evaluating the Northrop flying wing, he wrote down exactly what he thought of it. It was, in his words, the darndest airplane he had ever tried to do anything with. Quite uncontrollable at times. He was not writing for an audience. He was writing for himself, in the private language pilots use when they are trying to decide how much they trust a machine with their life. On Friday, June 4th, Edwards was frustrated. So was Major Daniel Forbes, the pilot he'd be flying with the next day, a man with his own distinguished combat record, now, like Edwards, spending his career at the edge of what aviation could survive. Neither man left behind a clear account of what exactly was bothering them that evening. What is known is that the next morning, June 5, 1948, both men climbed aboard the second YB-49 prototype for a routine performance test, alongside flight engineer Lieutenant Edward Swindell and 2 civilian engineers, Claire Lesser and Charles LaFountain. 5 men, 1 airplane with no tail. They took off from Muroc into clear California sky. For a while, the flight proceeded the way dozens of test flights before it had, climbing, leveling, running through the performance points the Air Force needed data on. Then, at some point during the sequence, the aircraft entered a maneuver from which the flying wing's fundamental shape gave it almost nothing to recover with. Investigators would never be able to say with total certainty what triggered it, whether the crew pushed the aircraft into a high-speed stall while gathering data, or whether a gust or control input sent it there unintentionally. What they could reconstruct from the wreckage scattered across the desert floor was the sequence of what happened next. The aircraft went into a violent spin. Without a tail to provide the resistance a conventional bomber would have had, the airframe could not fight its way out. The outer wings, the same wings that had carried the aircraft to records for speed, altitude, and endurance less than a year earlier, tore away from the airframe under the load. The rest of the aircraft, no longer flying, no longer even recognizable as the machine that had cruised over the Capitol, fell from the sky and struck the ground roughly 10 miles northwest of the base. Pieces of the wing structure were later found scattered more than 2 miles from the main impact site, an indication of just how high in the air the airplane had already begun coming apart. There were no survivors. All 5 men aboard, Forbes, Edwards, Swindell, Lesser, and LaFountain, were killed instantly. The Air Force lost a test aircraft that morning. It lost far more than that. Daniel Forbes and Glenn Edwards were not anonymous names on a flight manifest. They were 2 of the most respected test pilots the service had. Men who had already survived a war and chosen to keep risking their lives afterward, in the belief that someone had to fly the airplanes nobody had flown yet so that other men, someday, would not have to. Within 2 years, the United States Air Force would rename 2 of its bases in their honor: Forbes Air Force Base in Kansas and Edwards Air Force Base in California, the same stretch of desert where the flying wing had first proven itself and where, that June morning, it had just as decisively proven something else. It remains one of the strange, sobering footnotes of American aviation history that 2 men who would each have an Air Force base named after them died together, on the same aircraft, on the same morning. Inside Northrop's company, the crash landed like a physical blow. This was not an abstract setback measured in canceled line items on a production contract. These were men the engineers at Hawthorne had worked alongside, men who had trusted the company's calculations with their lives. Jack Northrop, who had spent nearly 2 decades insisting that his design was sound, now had 5 deaths attached to a shape he still believed in completely. He would go to his own grave arguing that the flying wing's aerodynamics did not work the way Cardenas and others described, that what killed the crew of June 5th was not an inherent flaw in the concept, but a set of conditions that better instrumentation, or more caution, might have prevented. It was, in its way, the same argument he had been making his entire career, that the flaw was never in the shape itself, and it was an argument that, after that morning in the Mojave, almost nobody outside his own company was still willing to fully accept. The Air Force did not cancel the program in the immediate aftermath. Testing on the remaining aircraft continued, cautiously, for nearly 2 more years, a decision that, in hindsight, looks less like confidence in the design and more like an institution not yet ready to admit how thoroughly the ground had shifted beneath it. But something had changed in the space of that one flight. The flying wing was no longer simply an experimental aircraft chasing performance records. It was now unmistakably an aircraft that had killed the men flying it, in a crash nobody could fully explain. And every setback that followed, every canceled contract, every closed-door meeting in Washington would carry the shadow of June 5, 1948, whether anyone said so out loud or not. Jack Northrop had built an airplane by removing everything from it that wasn't the wing. On a clear morning over the California desert, 5 men had discovered, in the most permanent way possible, exactly what that missing tail had been holding together. March 14, 1950. In the thin, cold air over Muroc, a Northrop test crew brought the last flying wing in America down for what neither they nor anyone else yet understood would be its final flight. The formal flight test program on the YB-49 was complete. There was nothing dramatic about the landing. It was simply the quiet procedural close of a chapter nobody had told the pilots was ending. The next morning, March 15, 1950, 2 things happened within hours of each other, and to this day historians still argue about how much of a coincidence that really was. First, the Air Force made it official. The YB-49 program was canceled. Second, that same afternoon, during a routine high-speed taxi test on the runway at Muroc, the sole remaining YB-49 prototype suffered a violent nose-wheel failure. The vibration tore through the airframe until the landing gear collapsed entirely, and the aircraft that had once flown non-stop across the country and cruised at nearly 500 miles an hour was consumed by fire on the ground it had never even left. In a single day, on paper and in the flesh, the Flying Wing Bomber program ceased to exist. What followed was not the slow, bureaucratic wind-down that experimental programs usually get. 2 months later, in May of 1950, Secretary of the Air Force Stuart Symington issued an order that went far beyond simply closing the books on a canceled contract. Every remaining flying wing airframe, the YB-35s and YB-49s, still sitting in various stages of storage and conversion at Hawthorne, was to be destroyed. Not mothballed, not placed in long-term storage the way the Air Force routinely handled canceled prototypes. Destroyed. Portable smelting furnaces were trucked onto Northrop's own property. Airframes that had taken years to design and build were cut into sections with torches and saws, fed into the smelters, and reduced to raw aluminum, in plain view of the engineers and machinists who had built them. Men who had spent a decade of their working lives on this shape watched it melt into ingots on the same tarmac where it had once taken off. Only one aircraft escaped temporarily. The YRB-49A reconnaissance prototype, the sole survivor of the 30-aircraft contract that had once seemed like vindication, was allowed to continue limited testing. It flew for the first time on May 4, 1950, and completed just 13 flights before the Air Force pulled its funding entirely in 1951. It sat abandoned in the open at Northrop's Ontario Airport for more than 2 years, exposed to the weather, before the Air Force finally ordered it scrapped as well, in December of 1953. Even the Smithsonian's attempt to save a single flying wing for its aviation collection was turned down. Symington rejected the request without explanation. There would be no museum piece, no static display, no physical trace left of the aircraft that had flown over the White House. The thoroughness of the destruction struck even people inside the Air Force as unusual, as if someone wanted absolute certainty that the flying wing could never be resurrected, studied, or vindicated by anyone in the future. Jack Northrop said almost nothing publicly for nearly 30 years. It was not until 1979, in a videotaped interview he gave near the end of his life, that he finally broke his silence and told the story the way he remembered it. He said Symington had pressured him directly to accept the merger with Convair, and that when he refused, the secretary made his intentions unmistakable. According to Northrop, Symington told him, "You'll be goddamn sorry if you don't." It is Northrop's account, not a verified transcript, and Symington, called before the House Armed Services Committee to answer allegations of political interference in the flying wing's cancellation, testified under oath that he had never pressured Northrop to do anything of the kind. The committee could not resolve the contradiction. What is not in dispute is the timing. Shortly after leaving his post as Secretary of the Air Force, Stuart Symington became president of Convair, the same company he had once urged Northrop to merge with. For Jack Northrop personally, the destruction of the flying wing was not a professional setback. He simply absorbed and moved past. He remained president of the company that bore his name for 2 more years, but colleagues who worked with him during that period described a man who had lost the fight that defined him. In 1952, at the age of 57, he resigned, divested his financial interest in the company, and walked away from the aviation industry almost entirely. He would not speak publicly about the flying wing again for nearly 3 decades. He turned to real estate investment in his retirement and lost a significant portion of his personal fortune in the process. A quiet, almost anonymous decline for a man who a few years earlier had been shaking hands with a president over the wreckage, or rather the triumph, of his own invention. For the men who had flown the aircraft and survived, the reckoning took a different shape. Robert Cardenas, the test pilot who had warned Glenn Edwards about the YB-49's dangerous stall characteristics, went on to a long career at the forefront of American flight testing, eventually flying chase planes for Chuck Yeager's supersonic flights and rising to the rank of brigadier general. He carried the flying wing program with him for the rest of his life, not as a triumph, but as a cautionary chapter in a career built on machines that pushed past the edge of what was known. And for the workforce at Hawthorne, the collapse meant something more immediate. A factory that had once been building America's most advanced bomber pivoted almost overnight to license production and subcontract work, building the F-89 Scorpion interceptor and components for other manufacturers' designs. Northrop Corporation survived as a business. It simply stopped, for more than 3 decades, being the company that built Jack Northrop's airplane. By the end of 1950, the flying wing existed almost nowhere except in blueprints, photographs, and the memories of the men who had built it, flown it, and buried 5 of their own beside it. The government that had once flown it over the White House had gone to extraordinary lengths to make sure that was all that remained. By the time Jack Northrop signed his retirement papers in 1952, there was, in the most literal sense possible, nothing left of the airplane he had spent his life building. Every XB-35 and YB-49 the Air Force had ordered destroyed was gone, cut apart, melted, and poured into ingots. Decades later, when a curious reader wrote to the Smithsonian's own aviation historians, asking whether any piece of a Northrop flying wing had survived anywhere in the world, in any museum, any archive, any private collection, the answer that came back was simple and final. No. Not a wing panel, not a cockpit section, not a single rivet. The most advanced bomber the United States had built in the late 1940s exists today only in photographs, flight test reports, and the memories of men who are almost all gone now too. Few aircraft in American history have been erased that completely. The company Jack Northrop founded did survive, even if the program that made him famous did not. Northrop Corporation spent the 1950s and 1960s rebuilding itself around license production and subcontract work, then found its footing again with aircraft like the F-5 fighter, and eventually a return to the kind of ambitious, independent design work Jack Northrop himself had once championed. In 1994, more than a decade after his death, the company merged with Grumman to form Northrop Grumman, the aerospace giant that still carries his name into the 21st century. But the real vindication of Jack Northrop's philosophy did not come through a corporate merger. It came through a program that began, quietly, in 1979, the same year Northrop, gravely ill and unable to walk, wrote to NASA to insist that his low-drag, high-lift flying wing concept still had scientific merit. NASA wrote back that the idea was technologically sound. It was a small, almost private confirmation, but for a man who had spent 30 years being told his life's work had been an engineering dead end, it mattered enormously. What Northrop did not know, what almost nobody outside a small circle of classified engineers knew, was that the Air Force had already launched a program called the Advanced Technology Bomber, aimed at building America's first true stealth aircraft. And when the engineers assigned to that program began searching for a shape that could minimize radar reflection, they rediscovered something almost nobody had thought to look at in 3 decades. Flight test data from the YB-49, which showed that its smooth, continuous flying wing surface had produced an unusually small radar signature purely as a byproduct of its aerodynamic shape. Nobody in 1948 had been trying to build a stealth aircraft. Nobody needed to be. The same principle that had once been sold purely as a drag reduction philosophy turned out, decades ahead of its time, to also be a stealth philosophy. Northrop's obsession with removing everything from the airplane except the lifting surface had accidentally solved a problem that wouldn't even have a name for another 20 years. In April of 1980, 2 engineers from the Northrop Corporation drove to Jack Northrop's home and asked for his help understanding what the flying wing's old test data could tell them about the new bomber taking shape in a classified hangar. He was 84 years old, confined to a wheelchair, and could no longer speak. They arranged for him to see it anyway. What he was shown, and what he held in his shaking hands that day, would not be named publicly for another 6 years. The Northrop Grumman B-2 Spirit, a stealth bomber with a wingspan of 172 feet. The exact same wingspan as the YB-49 the Air Force had ordered melted down 30 years earlier. On October 20th, 1981, the Air Force formally selected the Northrop Boeing team to build the Advanced Technology Bomber. Jack Northrop did not live to see it. He had died 8 months earlier, on February 18, 1981, of pneumonia, at Verdugo Hills Hospital in Glendale, California, 10 months after holding that model in his hands. He never watched the B-2 taxi down a runway. He never heard its engines. When it finally took its first flight on July 17, 1989, he had already been gone for more than 8 years. The aircraft that eventually entered service in the early 1990s was, in almost every way that mattered, his airplane, refined by 40 years of aerodynamics, computing power, and materials science. He never had access to, but built on the same central conviction he had carried since a workshop in Santa Barbara in 1916, that anything on an airplane that wasn't producing lift was something worth removing. The fly-by-wire flight computers that finally solved the stability problem that had killed 5 men in 1948. Technology that could react to a flying wing's instability thousands of times per second, far faster than any human pilot's hands, were the missing piece Northrop's generation simply did not have. In 1991, the Air Force, Boeing, and Northrop jointly received the Collier Trophy, American aviation's highest honor, for the design and development of the B-2. The aircraft remains in service today, one of the most capable and secretive bombers ever built by any country on Earth. The historical verdict on Jack Northrop is, in the end, a strange and split one. The Air Force's official position was that the flying wing was canceled for legitimate technical and budgetary reasons. Northrop went to his grave insisting that a political grudge had done what physics never managed to do. Both explanations may hold a piece of the truth, but the engineering itself, the pure radical idea that a bomber could be built out of nothing but wing, was never actually wrong. It simply arrived 30 years before the computers existed that could keep it flying straight. History rarely offers an engineer that kind of vindication while there is still time to enjoy it. Jack Northrop got exactly 10 months of it, in a darkened hangar, holding a model he could barely lift. Two men, at nearly the same moment in history, looked at the same impossible requirement and answered it in opposite languages. One of them built by addition: more engines, more fuel, more structure, more armor, more redundancy, until the specification sheet was satisfied by sheer accumulation. Convair's answer became the largest piston-engine aircraft ever built, a machine that succeeded in the end by refusing to leave anything out. The other built by subtraction: no fuselage, no tail, no structure that did not, itself, produce lift. Jack Northrop's answer was not to add until the requirement was met. It was to strip away until nothing remained but the one surface doing the actual work of flight, and to trust that physics, stripped of everything unnecessary, would carry the rest. Addition is forgiving. It builds in margin, redundancy, a cushion for the things engineers cannot yet predict. Subtraction is not. Subtraction has no cushion. Every ounce Northrop removed made the airplane faster and more efficient, and every ounce he removed also took away one more thing that might have caught it, steadied it, saved it when the moment came that it needed saving. That was never a flaw hidden inside the design. It was the design. The same absence of a tail that let the flying wing outclimb, outrun, and outlast anything else in the American arsenal was the exact absence that let it tumble out of the sky over the Mojave on a clear June morning with nothing behind it to hold the line. Northrop knew this trade before he ever built the first prototype. He made it anyway because he believed the gain was worth what it cost, and because he never stopped believing that the missing piece was not a mistake in his philosophy, but a problem technology simply hadn't caught up to yet. He was not wrong. He was only early. 40 years is a long time to be right and unable to prove it. It is a long time to watch a rival's heavier, more forgiving answer win the contract, win the funding, win the argument in every room that mattered, while the truth sat quietly in a stack of flight test data nobody thought to look at again, until a new generation of engineers, chasing a different problem entirely, found it waiting for them exactly where he'd left it. He spent 30 years in near silence, having built and lost 3 companies chasing one shape. He spent his final year of health finally allowed to say, out loud, what he believed had really happened to his life's work. And he spent his last conscious months of clarity in a darkened hangar, in a wheelchair, holding a model of an airplane that would not exist in the world he could still perceive. An airplane that was, in every measurement that counted, simply his airplane, finished by other hands, decades after the government had melted down every trace of the original with its own smelters, on his own factory floor, in front of his own employees. He never got to hear the engine start. He never got to watch it climb. What he got instead was one afternoon and one sentence, written in a shaking hand on a scrap of paper that no one who was in that room ever forgot. He had waited 50 years to be told he was right. In the end, it took a dying man's borrowed decade and a wing shaped exactly like the one they melted down to say it.